Alright, welcome! So in this video, we are going to talk about how we graph sinusoidal functions. So this is an introduction to sinusoidal graphs. So in this video, we're going to figure out the graphs for sine and cosine. So to start, I'm going to go back to our unit circle, and these points on the x and y axes are going to be our basis for graphing the sine of theta and the cosine of theta functions. So really briefly, we need to remember that sine and cosine are functions of theta. So theta is the input, so we could say we have f of theta equals sine of theta, and g of theta equals cosine of theta. So theta is the input, then the output is the sine of theta value or the cosine of theta value. So we give this function an angle, and it tells us the sine or the cosine. So to get us going on the graph, let's start with the sine function, and we're going to just do some input-output values. So similar to how you might do like an x, y table if you were graphing a function with x and y, here we're going to try it again with theta and sine of theta. So I'm going to focus on the first quadrant first. So let's do 0, pi over 6, pi over 4, pi over 3, and pi over 2 as our angles. As a note, I'm going to use radians. I like to use radians, and I think it helps get students more comfortable with them since they're used to degrees in many cases. So by using radians, this will hopefully just get you used to them a little better. But the angle measures are on the picture here on the unit circle, so you have them available to you too. So if we're looking at sine of theta, sine is the y value here on the unit circle, so I just need to look at the y coordinate for all of these points. So for an angle of 0, I have 0 as the sine. The angle of pi over 6 has 1/2 as the sine. Pi over 4 is square root of 2 over 2. And pi over 3 is square root of 3 over 2. Then lastly, for pi over 2, our output is 1 for sine. Okay, so we have our first 5 points that we could graph here. I have our input values for theta and the output values that go with them. And to help us out to graph these, I'm going to calculate some decimals for these. So 1/2 is 0.5, and then if I type in my calculator square root of 2 divided by 2, I'm getting about 0.71, and then for square root of 3 divided by 2, I'm getting about 0.87. So having these will help us graph. Okay, so let's look at some axes. So here I'm going to label the horizontal axis as theta, so my input is that horizontal, and then the output is f of theta, which is sine theta. And so I have, instead of x and y, I have theta as my horizontal and sine of theta, the output values, as my vertical. Now our goal is to plot these input and output points. So I know that my outputs are 1/2, root 2 over 2, and root 3 over 2, which I'm going to label here. So I have a 1/2, which is halfway between 0 and 1, and then I'm going to just do my best to plot these other points. We'll see the official graph using Desmos at the end of this, but I'm just going to start by doing my best sketch here. Then we can go ahead and start plotting our points. So the axes I have here only have pi over 4 and pi over 2, so I'll add in pi over 6 and pi over 3, and let's get going. So I have 0, 0 as my first point. Then my next point is pi over 6 on the horizontal and 1/2 on the vertical. Then I have pi over 4 and root 2 over 2, which is about 0.71. For pi over 3, I have about 0.87, or square root of 3 over 2. And then for pi over 2, I am up at 1. Alright, so we have a little part of this, and let's go to the second quadrant now. So you'll notice if we look at the sine values, or the y coordinates of these points, we're getting the same values, and they're also still positive. I don't really know how to talk through this without it being incredibly boring, so hopefully you can follow along that we start at 1 on the sine, and we are slowly going down to 0 as we look at those y values changing as we move through quadrant 2. And here, I'll plot those points. Alright, so we have this first section, and now we need to figure out quadrants 3 and 4. So quadrants 3 and 4 have negative sine values since they have y values that are negative. They're below the horizontal axis. So the same pattern is going to repeat, so we're similarly below the horizontal axis. So I'm just going to take the part of the graph I've already drawn and reflect it down here. And there we go. I've done the whole 0 to 2 pi portion of this graph. Now you can imagine that if we went the other way around the unit circle, so we did negative angles to get the other part of our graph here, the same pattern is going to go. So we have negative sine values first, then we go to positive sine values. So my function is going to look something like this. Let's graph it in Desmos so you can see a more official graph draw out. So in this animation, we see the angle going around the circle, and as it goes, we are drawing out the output values for sine. So when we're in quadrants 1 and 2, the output is positive, so we are above the horizontal axis. Then when we move to quadrants 3 and 4, our sine is negative since the y would be negative on the circle, and so our outputs are below the horizontal axis. And there you go. We can imagine this continuing to go around and around as we draw out the graph. Let's repeat this process with cosine. So I'm going to say we have g of theta equals cosine of theta, and now we're going to look at an input of theta and an output of cosine. So on our unit circle, cosine is the x value, or the x coordinate of all these points. So I'm just going to go ahead and circle all of those and write them out on my chart. So an angle of 0 has an output of 1 for cosine, pi over 6 goes with square root of 3 over 2, pi over 4 is square root of 2 over 2, and pi over 3 is 1/2. Then when we get to pi over 2, our cosine is 0. So this is similar to sine, except we're starting at 1 as our output, and we're moving our way down to 0. So when we go to graph it, I have my basic setup that I used with sine, but now we're starting at 1, so 0, 1 is our first point. Then I have pi over 6, root 3 over 2, etc., until I get to pi over 2, which has an output of 0. And so looking at this, you can imagine the pattern continues. So as we get to quadrant 2, the cosine values are negative, so we're going to be below the horizontal axis on our graph. Then in quadrant 3, the cosine values are also negative, so we'll still be below the horizontal axis for that section too. So we've done our positive cosine values in quadrant 1, and now we're going to do negative cosine values. So our graph continues below the horizontal axis, and then for 3 pi over 2, we're back to 0 as our output. Then in quadrant 4, our cosine values, the x values on our unit circle, are positive, and so we're back above the horizontal axis on our graph. And so here, the cosine graph looks similar to the sine graph, except we start up at 1 at that 0 input. We can see the same animation using Desmos, so as the angle sweeps around the circle, we can see the cosine values drawing out. When the cosine, or the x, is positive, that's in quadrants 1 and 4, we are above the horizontal axis, and when they are negative in 2 and 3, we are below. So now that we've graphed these functions, let's go through some vocabulary. So sine and cosine are called periodic because they have repeated behavior after a certain period of time. So we saw that as the angle goes around the circle, as it continues to make more revolutions, the graph is going to repeat itself. So this repeating behavior is called periodic, and we'll get back to that word in a minute. This specific type of periodic is called sinusoidal. So that's the word I used at the beginning to introduce this video, and you can connect that word to the types of functions we're looking at because we have sine and cosine, and these are sinusoidal functions. So it's just another specific way to talk about how they are periodic. We can have different types of periodic functions that repeat themselves, and this specific type is sinusoidal. Then we also will use the word oscillate to describe how the function moves back and forth. So you've probably heard this word outside of a math context, and we use it in math too, just to indicate that the function is sort of bouncing back and forth between these values as it continues to repeat itself. Then we have 3 characteristics that we use to describe periodic functions. These characteristics are period, midline, and amplitude. So on our sinusoidal functions, period means the distance between inputs where the function begins to repeat itself. So we basically just want to know how long, in terms of input values, does it take for the function to begin a new cycle, to start its repetition again. Then midline refers to the line that represents the middle of the function. This one's pretty self-explanatory for what it means. Then the amplitude is the distance between the midline and the highest or lowest value of the function. So you can imagine from that midline up to the top of the function or to the bottom of the function. The amplitude is that distance. So before we go, let's use these words to talk about our sine and cosine functions. So if we look first at our sine function, let's do the period. So the period we can usually find by finding 2 points that have the same output. So if I look at 0 as an input and 2 pi as an input, they both have an output of 0. So I'm going to circle those points. Then we can see the function does one full cycle between those points. So from 0 to 2 pi, it does a whole bunch of stuff, but then it starts to repeat itself after that. You can also look to the left and see that it's the same repetition is happening. So we would say that the period is 2 pi. That's the distance between those circled points. It takes 2 pi on the input in order for the function to continue repeating itself. You could do the similar thing by looking at different points with the same output. So maybe negative 3 pi over 2 and pi over 2, where both of the outputs are 1. So if we look at the distance between these 2 points, that's also 2 pi. So you just need to find 2 points that have the same outputs and see what the distance is between them. Then the midline is the line that divides the function in half, basically. It's just the middle of the function. It should be a horizontal line too, so I'm seeing that the axis, the horizontal axis, is our midline, which is the line y equals 0. You can sort of see that the amount of function that's above the line and below the line are the same. So there's a distance of 1 up to the top of the function and a similar distance of 1 down to the bottom of the function. And this will also help identify the amplitude. So the amplitude is specifically this distance from the midline to the top or the bottom of the function. And so here our amplitude is 1. Let's repeat this with cosine. So we're going to find the period, midline, and amplitude. Again, let's identify some points where the outputs are the same. I'm going to do negative 2 pi, 0, and 2 pi. All of these have outputs of 1. So you can see that the distance between them is 2 pi. So basically it takes 2 pi on the input for the function to start repeating itself. You can do a similar thing here where you pick different points. You could pick maybe negative pi over 2 and 3 pi over 2 and see that the distance between them is 2 pi. The main idea is you just need to pick points where you can tell the distance between them. Then our midline is the same, it's y equals 0, and the amplitude is the same as well, it's just 1. So there we have it. That's an introduction to our sinusoidal functions, specifically the graphs of sine and cosine. Thanks so much for watching, and I will talk to you in the next one.